Good day, friends. Welcome to my channel, lecture series in power electronics. In this lecture, we'll see about the EMF equation of a DC generator. Before going into the EMF equation, let us see the constructional details of the simple 4-pole DC machine. This is the structure of a DC machine. It is having 4 poles here, and the armature conductors are shown as small dots over here. So for derivation of the EMF equation of the DC machine, we need to assume certain things like the number of poles. In general, in this machine we have taken as 4, and let us say P as the number of poles, and the number of conductors, total number of conductors, we are going to take it as Z, and the flux under every pole is assumed to be phi. Let us see this. We are assuming P as the number of poles in the machine. Phi is the flux under single pole. Z is the number of conductors, and N is the speed at which the armature is going to rotate, and it is given in RPM, revolutions per minute. A is the number of parallel paths in the armature winding. The number of parallel paths is decided by the type of winding. If it is a lap winding, then A is equivalent to P, and if it is a wave winding, A is always taken as 2. To understand the EMF generated in a DC machine, the small dots shown here are the armature conductors. Let us take one of the conductors and say what is the EMF induced in that conductor, then multiply the value obtained by the total number of conductors present here. So let us take one conductor here, and when it is in this position, it is subjected to the magnetic flux under this pole. As it rotates, it comes across the flux under every pole. For this particular case, this conductor will be subjected to 4 times the flux, 4 phi. So, but in general, it is, if the number of poles is P, in general it is P phi, but this particular conductor is subjected to 4 phi. And let us say that this armature is rotating in the magnetic field with the speed of, say, 1 revolution per minute. 1 revolution. It is making n revolutions. Let us say 1 revolution of every conductor will induce a EMF in it. Let us assume that it is making n revolutions in a minute. If it is making n revolutions in a minute, how much time will be taken for 1 revolution? Say time for 1 revolution is 1 by n minutes. If it is rotating at a speed of n revolutions per minute. If it is rotating at a speed of, say, 1000 RPM, 1000 revolutions in a minute, then time taken for 1 revolution will be 1 by 1000. In general, it is taken as n. It is 1 by n minutes, or in terms of seconds, we multiply this by 60. It is 60 by n seconds. So we have found out 2 things. One is the flux for which the conductor undergoes, and the speed at which it is rotating. The EMF induced in a conductor is given by the rate of change of flux. How much flux is changing with respect to time. So here we have seen that it is subjected to P phi, and it is rotating at a speed of n revolutions per minute. So now if we change this to revolutions per second, d phi by dt becomes P phi flux divided by the time, 60 by n. So P phi by 60 by n is rewritten as Np phi by 60. This is for a single conductor. One conductor is having a EMF induced as this Np phi by 60. If we have, say, Z conductors, then we multiply that by Z, and the EMF induced in the entire armature becomes N into Np phi by 60, which is written as phi Z n by 60 into P divided by A. So this is the number of parallel paths. If it is a lap winding, A is taken to be equal to P, and if it is a wave winding, A is taken to be equal to 2. EMF induced in the entire armature is given by Eg is equal to phi Zn by 60 into P by A, where phi is the flux under every pole, Z is the number of conductors, N is the speed at which the armature is rotating, P is the number of poles, A is the number of parallel paths. So this is the EMF induced in a generator. It is represented by Eg. That is generated EMF. In the case of a motor, the motor is, when we give the supply to the armature, the motor will start rotating in the magnetic field. So when the motor is rotating in the magnetic field, when the armature is rotating in the magnetic field, there will be EMF induced in the armature of a motor also. And that will be opposing the main voltage what is given to the armature. So in that case also, the EMF induced is given by the same expression, but it is represented as EB because it is opposing the supply voltage. It is written as EB, but the expression remains the same. So as it rotates, it is generating a voltage which is opposing the main voltage. Now the EMF induced in a DC generator is given by phi Zn by 60 into P by A. The same is given for the motor also. It is represented as Eg for the generator, but it is represented as EB for the motor. So this gives the expression for the EMF generated in a DC machine. Thank you.